Okay, everybody. So now I will talk about important techniques in solving problems on limits. Yes, definitely. Limit is one of the important chapter in calculus. And if you are preparing for mains, advanced and all India level JEE exams and also different engineering exams, so you have to well prepared for function, limit, continuity, differentiability. So limit is the most important because it will link the entire calculus chapters. So let's talk about straight to the problems. Problem number one, let p equal to limit x tends to 0 plus 1 plus tan square root over x whole to the power 1 over 2x. Then your log p is equal to, what is your log p? You have to find out. Now first of all, first observation is that if x tends to 0, 1 plus tan square x, 1 plus tan square root x, that will tends to 1. If x tends to 0 plus, this is actually tends to 1, and 1 over 2x, that tends to infinity. That tends to infinity because x tends to 0 plus, so it will goes to positive infinity. So this problem is of the form 1 to the power infinity. This is your first observation. If you have a limit problem, please check whether your power is goes to infinity and your base is goes to 1, then it is of the type 1 to the power infinity. Now this is your first observation in the if you are attempting a problem in JEE mains advanced or any engineering exam. So this is your entrance exam. So this is your first observation. Next, I will give you some theoretical knowledge how to deal with the problems of 1 to the power infinity. So how will you deal? Let let us suppose that limit x goes to L is equal to limit x goes to a fx to the power gx, and in this case also I am supposing that limit x tends to a fx equal to L 1 and limit x tends to a gx equal to infinity. Then L equal to limit, then L equal to limit x goes to a fx to the power gx. That can be written as, I'm writing this, look at that how I am writing. I'm writing inside the base, I'm written as 1 plus fx minus 1. So minus 1 plus 1 cancel and we are remain with fx. So I hope there is no problem with writing this. Whole to the power, I'm writing this extra part what I'm taking because my target is to form 1 plus something, 1 plus x. Suppose this is your x. This entire thing inside the open bracket is x, capital X. So I'm writing 1 plus x and whole to the power 1 by x. So this is the extra part because you had a gx, but I have 1 over fx minus 1. So I have to nullify fx minus 1 in such a way that you are remain with gx in the power only. So I'm multiplying with fx minus 1. So that is the simplified. This is the step. Okay. Now, so I'm writing in the closed bracket limit x goes to infinity 1 plus fx minus 1 whole to the power 1 over fx minus 1, this entire thing inside the closed bracket, and that is nothing but your E, Euler number, and whole to the power limit x goes to a fx minus 1 gx, this extra part. Now why I am writing E? So some results are given here also for your better understanding. Limit x goes to 0, 1 plus x whole to the power 1 over x is E. Limit x goes to 0, 1 plus x whole to the power 1 by x is E. So I'm writing in that format only, 1 plus x whole to the power if this is the thing. And if limit x goes to infinity, 1 over 1 plus x is whole to the power x is also E. So these two results will use. It depends on the problem actually. So you have this. So ultimately this is the result. This is the final trick you have to put in the problem. No need to calculate during the exam. You just directly substitute this one. Directly. E to the power limit x goes to a fx minus 1 gx. That you can substitute that and you can calculate directly. L equal to e to the power limit x tends to a fx minus 1 gx. That you can do it directly. So in your problem, what is your fx? In your problem, fx is tan square root over x. Okay, in your problem, what is your fx? So let me put a page here. Let me show you. Yeah, in your problem, what is your fx? Your fx is 1. Your fx is 1 plus tan square root over x. Okay, this is your fx. So, and what is your gx? Gx is 1 over 2x. Okay, so I'm writing p equal to e to the power limit x tends to 0 plus gx into fx minus 1. That's the form actually. That's the form directly plugged into this form. This is the form. This is a shortcut trick. You don't have to calculate so much. So this is your e to the power. That's gonna be e to the power limit x tends to 0 plus what is your gx? 2x times tan square root over x, because plus 1 minus 1 gone. This is the thing. So this gonna be e to the power limit x tends to 0 plus tan x half tan root x over root x whole square, and that's gonna be okay, that's gonna be e to the power half, because this is 1, this is 1. So what is your log p? Log p is nothing but your half. So that is your answer. Okay, so this is the calculation. So look at the option. Yeah, option is 3, third option, C. So this is the how you are using 1 to the power infinity. Let's move on to the next problem. Problem number 2. Yeah. So next problem is the value of limit x goes to 0, 1 plus x whole to the power 1 over x minus e plus half ex over x square is. You have to find out the which one is the correct answer option. So look at that. You have 1 plus x whole to the power 1 over x minus e and half ex. So let me use some series expansion. Actually, in limits, if you know some series expansion, your problem will be much easier to solve. So let us have, because you have e, so let us have some series expansion. This is your first one is a sin x. Sin x is x minus x cube by factorial 3 plus x to the power 5 by factorial 5 minus x to the power 7 by factorial 7 plus etc. Number 2 cos x, that's gonna be 1 minus x square by factorial 2 plus x to the power 4 by factorial 4 minus x to the power 6 by factorial. So you have all are even powers actually in cos. And tan x, x plus x cube by factorial 3, it's very difficult to understand because the series expansion are actually came from Taylor series expansion, that is very higher dimension mean value theorem. And you have to remember actually sine, cos, exponential and log, these three are these four are important. Tan is not required always. Exponential e to the power x is 1 plus x square by factorial 2 plus x cube by factorial 3 etc. Similarly you can do e to the power minus x. And number 6 is 1 plus x whole to the power, that is your binomial expansion. Binomial expansion for x in less than 1, in less than a fraction, then you have 1 plus nx n into n minus 1 by factorial 2x square. This is your binomial expansion for less than 1 fractional index. And you have 7, that is ln 1 plus x, that is x minus x square by 2 plus x cube by 3 etc. But this is valid when minus 1 less than x less than equal to 1. So let's solve this problem using some series technique. So first of all, just observe this 1 plus x whole to the power 1 by x, let it be y. Let it be y. 1 plus x whole to the power 1 by x, that is going to be y. So ln y is, if you take ln, so that's going to be 1 by x ln 1 plus x. Okay, you need a expansion of ln 1 plus x. Okay, so if I write the expansion 1 plus x, you know that ln 1 plus x is this one, x minus x square by 2 plus x cube by 3 etc. So it's x minus x square by 2 plus x cube by 3, okay, minus x to the power 4 by 4 plus etc. Okay, this is the series expansion of ln 1 plus x. So you have y is e to the power this. So let me put some page here. Yeah, so what is your y gonna be e to the power, this x get cancelled, so y 1 minus x by 2 plus x square by 3 minus x to the power 4 x cube by 4 plus etc. Okay, this is your exponential. Now this can be written as e to the power into e to the power minus x by 2 plus x square by 3 minus x cube by 4. You can do with me also, together we can do. So this is your e into e to the power. Now this can be written as, if we do the exponential series expansion, suppose this entire thing is, if this entire thing is capital X, then you have a e to the power x expansion. So what is your expansion for e to the power x? Once again I want to show you, 1 plus x squared by factorial 3, 2 plus x cube by factorial 3, etc. So it's gonna be 1 plus minus x by 2 plus x squared by 3 minus x cube by 4 plus and 1 by factorial 2 plus 1 by factorial 2 and whole square of this, that is minus x by 2 plus x squared by 3. So I'm using a lot of expansion, exponential, log, etc, etc. This gonna be squared, okay, and so on. It's an infinite series expansion. So now you look at that. So this side you have y, and if you multiply this is e, and this is minus ex by 2. So I'm bringing back this side, I'm transposing e plus ex by 2. Okay, so and the right hand side you can take x squared common, so ex squared on the right, and this is 1/3. If you take x squared common from here, if you take x squared common from here, you have 1/3. Okay, plus all other terms are x. I'm writing this order of x, that is all terms contain x, all other terms are contain x because you have a multiplied with x. So I'm writing order of x plus half the next one, you see the next one, this is whole squared, actually this is whole squared, this is whole squared, you see this is whole squared, so this is x squared. So I've taken x squared common, so this gonna be minus half. Okay, if I take x squared, so this is gonna be minus half, and all other terms are order of x. Okay, and that's gonna be whole squared plus etc. Okay, clear? So this is the calculation. So now now your limit, look at the limit. What was the problem? This is your y minus e plus ex by 2 whole to the power x squared. So I have x squared here, so you can take this limit x tends to 0, y minus e plus ex over 2 over x squared equal to 1/3. E is there, and you have remain with 1/3 because x tends to 0. That means this order of x, all terms having x are 0, and you are remain with minus 1/4. That's only. Oh, minus half squared, that is 1/4 into half, that is plus 1/8. This is the calculation. So you have 11e over 24. That's a very important problem because using series, otherwise you can't do that problem. So you are using series or other techniques, you have this, and also some expansion, infinite series expansion. So let's check the option. Option is 1, 11e by 24. So this is the answer. Okay, everybody. So let's move to number 3. Yeah, let's move to number 3. So for number 3, fx equal to limit n tends to infinity ln 2 plus x minus x to the power 2n sin x over 1 plus x to the power 2n. Then you have 4 options. F is continuous at x equal to l. So actually continuity, for continuity the limit has to be exist and the limiting value must be equal to the functional value. That is the continuity. Number 2, limit x tends to 1 plus fx not equal to limit x tends to 1 minus fx. Number 3, limit x tends to 1 plus fx equal to sine 1. And number 4, limit x tends to 1 minus fx does not exist. So you have to test the limit actually, first of all. Now I will give some idea about n tends to infinity x to the power 2 and some theorem, important theorem. Let me talk about. So this is the theorem. If p is positive, and limit n goes to infinity, 1 by n to the power p is 0. If p is positive. And if n becomes larger, then this goes to 0. That is number 1. And number 2, if p is positive, nth root of p will be 1. That is number 2. Nth root of p will be 1. Number 3, nth root of n will be 1 if limit n goes to infinity. I'm not going to prove anything. I'm just giving you the logic. If p greater than 0, alpha is real, this limit is 0, but this is important. This is the important one. If mod x less than 1, then limit n tends to infinity, x to the power n is 0. If mod x is less than 1, limit n tends to infinity, x to the power n is 0. Okay, so this is the important thing. So let's come to the problem. You have x to the power 2n. So if mod x less than 1, x to the power 2n tends to 0 as n goes to infinity. Okay, and if mod x more than 1, 1 over x to the power 2n tends to 0 as n goes to infinity. That is from that theorem, and this is very important concept. If mod x less than 1, x to the power 2n tends to 0 as n tends to infinity. If mod x more than 1, 1 over x to the power 2n tends to 0 as n tends to infinity. Okay, so now let's solve this problem. Now let us write fx in a modified form. So that's gonna be, yeah, okay, this is the problem. So this is the problem. Okay, so now your fx will be ln 2 plus x if mod x less than 1, because x to the power 2n will be 0, x to the power 2n will be 0, so this second term and the denominator will be 1 only. So you have ln 2 plus x, and limit n goes to infinity. I'm dividing by x to the power minus 2n, x to the power 2n, so it's gonna be x to the power minus 2n ln, it's gonna be ln 2 plus x minus sin x over x to the power minus 2n plus 1 if, and that's gonna be minus sin x, because this part will be 0. Why this part will be 0? Because if mod x is more than 1, if mod x is more than 1, x to the power minus 2n tends to 0. Look at that. If mod x less than, greater than, more than 1, 1 over x to the power 2n will tends to 0 as n goes to infinity. Okay, and if mod x equal to 1, that's gonna be half ln 2 plus x, because denominator will be half, and minus sin x. if mod x equal to 1. So this is your fx now. Now check limit x goes to 1 plus fx. What is that? Limit x tends to 1 plus fx. 1 plus fx, that is equal to minus sin x, actually minus sin 1, because that is this one, this function. You have to select this one, you have to choose, because mod x is more than 1, that is minus sin 1. And limit x tends to 1 minus fx. So x is less than 1, that is limit, if less than 1, that is the first part, first function. If mod x less than 1, that's gonna be limit x tends to 1 minus ln 2 plus x, that is ln 3. So what is your, this is 1 plus, left hand limit and right hand limit are not equal. So what is your option? Option is number 2. Limit x tends to 1 plus fx not equal to limit x tends to 1 minus fx. Okay, this is the option, left hand limit not equal to right hand limit. And this is very, very important, because a lot of concept is involved here, especially the concept of mod x less than 1, x to the power 2n tends to 0, and mod x more than 1, 1 over x to the power 2n tends to 0. That is the important concept here. Okay, next I will move to the next problem. What is your number 4? Number 4 is a easy one, because you have limit x goes to 0, log base 10 square x tan square 2x. What is the evaluate? You have to evaluate this one. This is quite easy, but what is the logic behind that, how to do it? So I'm using L'Hopital's rule. Sometimes it's pronunciation L'Hopital's. Okay, so I'm using L'Hopital's rule. So let me describe this. Suppose f and g are differentiable, that is you can draw tangent for these functions, and g dash x not equal to 0 on an open interval I that contains a, except possibly at a, and suppose that limit x tends to a fx equal to 0 and limit x tends to a gx equal to 0, or that limit x tends to a fx equal to plus minus infinity and limit x tends to a gx equal to plus minus infinity. So as x tends to a, fx tends to 0, or limit x tends to a, fx tends to plus minus infinity, gx tends to plus minus infinity, that's it. But provided g prime is not equal to 0. In other words, we have an indeterminate form of the type 0 over 0 or infinity over infinity. That is the important forms, 0 over 0 or infinity over infinity. Then limit x goes to a fx over gx equal to limit x goes to a f prime x by g prime x. Then limit x goes to a fx over gx equal to limit x tends to a f prime x by g prime x. If the limit on the right hand side exists, or is minus infinity or minus minus infinity. So that is actually L'Hopital's rule. So let's use this one. First of all, let me write this one as limit x tends to 0. I'm using properties of log, base change properties. So this is gonna be log tan square 2x. If nothing is mentioned, it is ln log e base log tan square x. So okay, this is infinity by infinity form, because tan 0 0, so log 0 is undefined, infinity, and log 0 is, so this is infinity by infinity form. We can apply the L'Hopital's rule. So I'm using limit x tends to 0. I'm differentiating the numerator 1 over tan square 2x. That's gonna be 1 over tan square 2x into derivative of tan 2x, that is 2 tan x, 2 tan 2x times x squared 2x again the derivative of 2x, that is 2 over 1 over tan square x, 1 over tan square x times 2 tan x into sec square x. Okay, and that's gonna be limit x tends to 0 to 1 over, if you simplify, I have the simplified result, sine 2x cos 2x, just put it into the form of sine 2x, sine x by cos x tan, just convert, and over sine x cos x. So that's gonna be limit x tends to 0, 1 over cos 2x, and that's gonna be 1. Sometimes you have to differentiate again if it is a form of 0 by 0 or infinity by infinity, otherwise it is okay. Okay, so that's the answer. So your answer will be cos 0 is 1. Oh, answer, I think some is printed here, it should be some one of the option will be 1, so let it be 1. Okay, so answer is 1. Okay, so I'm using L'Hopital's rule, maybe more problems for L'Hopital's rule here. Yeah, I have another problem. This is the recent problem in JEE. If fa is 2, f prime a is 1, ga is -1, g prime a is -2, then what is your limit x tends to a, gx fa minus ga fx by over x minus a? So if you plugged a, then that's going to be clearly 0 by 0 form. The previous one was infinity by infinity form, the previous one. This was 0 by 0 form. So I'm going to use that L'Hopital's rule, L'Hopital's sometimes pronounced as. So limit x goes to a, g prime x fa, because fa is constant, minus g a f prime x over 1. Now look at that. If you plugged a here, the denominator cannot 0, and if you plugged here g prime a is -2, that's gonna be -2 if a is 2 times 2 minus ga is -1 times a prime a is 1. So this is your result. So -3 is the answer. So third option. So using L'Hopital's rule, your problems are very easy. If you can apply your L'Hopital's rule, if you can identify, you have to identify the problem, whether the problem is 1 to the power infinity, whether the problem is L'Hopital's, whether the problem is a 0 by 0 forms, or whether the problem will x to the power n type. So there are a lot of rules actually. Next, this is also very important problem. This is limit x goes to infinity. Sorry, this is gonna be n tends to infinity. This is not x goes to infinity. This is gonna be n tends to infinity. A printing mistake, typographical error. So box x, this is box x, greatest integer function. Box x plus box 2x plus box 3x, etc. box nx over n square. And what is the result of this limit? So I'm going to use, for this problem, I'm going to use sandwich theorem or squeeze theorem. Let me show you. Yeah, sandwich theorem, also known as squeeze theorem or pinching theorem. So if gx, look at that, if gx less than equal to fx less than equal to hx for all x in some open interval containing x equal to c, except possibility at c itself, and if limit x tends to c gx equal to l, limit x tends to c hx equal to l, then limit x tends to c fx equal to l. So if the lower limit goes to L, upper limit goes to the in equations, the left hand and the right hand goes to L, then fx should goes to L. So that is the sandwich theorem. And look at the graph, it's between okay, so this is the theorem. So I'm going to use this theorem actually for solving this problem. Now before that, let me add a page here. Yeah. So we know that if you're writing box is actually x minus 1 less than equal to x. So box x lies between x minus 1 and x. Similarly, box 2x lies in between 2x and 2x minus 1. Okay, 2x, sorry, 2x minus 1 here, and that's gonna be 2x here. And similarly, 3x less than 3x minus 1 and less than equal to 3x. And so on, you are writing nx, box nx, that's gonna be nx minus 1 less than equal to nx. Now you are adding both the sides. If you are adding both the sides, that's gonna be x into n plus 1 by 2 minus n over less than x plus box 2x plus etc. box nx less than equal to, if you take the sum, arithmetic GPC, arithmetic progression, n into n plus 1 by 2 times x. Okay, and you have n squared, and limit n goes to infinity. So I'm taking limit n goes to infinity and dividing throughout over n squared. So it's gonna be nx into n plus 1 minus 2n over 2n squared less than limit n goes to infinity box x plus box 2x etc., and that's gonna be box nx over n squared. Okay, and less than equal to limit n goes to infinity n into n plus 1 by 2 n squared x. Okay, and this limit is x by 2. You can easily verify. If you divide by n squared, you will get x by 2 here, and here also you will get x by 2. So according to Sandwich theorem, your this limit goes to x by 2. So I'm using Sandwich theorem here. This is very, very important concept actually. So this is gonna be x by 2, so that is 2. Okay, one more problem I will show you using using this sandwich. So I'm using squeeze theorem or sandwich theorem, this one. Let's have a problem number 7. So wait, yeah, okay. Using squeeze theorem, so that limit t tends to 0, t square sine 1 over t is 0. Actually sine 1 by 2 is a bounded function and t square tends to 0, so the product will goes to 0. Naturally there is a theorem, but I can use a squeeze theorem also. So you look at the sine 1 over t is bounded between minus 1 and 1, multiplying throughout by t square, and this one, the left hand is goes to 0 and the right function goes to 0. So according to Sandwich, this goes to 0. Otherwise there is a theorem. What is the theorem? Suppose you have a product, limit x goes to 0, fx into gx. You have to evaluate. If gx is a bounded function and fx goes to 0, then this limit goes to 0. That is the theorem. If gx is a bounded function, it is bounded in the neighborhood of 0, not naturally at 0, doesn't exist at 0, but it is bounded in the neighborhood of 0, and fx goes to 0, then this product goes to 0. Using this, you can solve so many problems. So this is also very, very important type of problem. You have a lot of application on this problem, because you can put it x square sine 1 by x, x square cos 1 by x, x cube cos 1 by x. So many problems can be framed. Next is the Next type of problem, you see, this is a very special type of problem. Maybe you don't know integration. I will talk about integration here. This is the integration sign. So if you do integration upper limit minus lower limit, that is the process actually. So inside the limit there is the integration. Okay. Now as x goes to pi by 4, so sec pi by 4 is root 2, so that's gonna be 2. So if you have the same limit, the upper limit will be 0. If you have the same limit, then the upper limit is 0. Upper portion, that is the fx numerator, will be 0, and the denominator will be 0 also. And the denominator, so this is all the form of 0 by 0. So if this is of the form of 0 by 0, we can use L'Hopital's rule. So if you apply L'Hopital's rule, this is the derivative under the integral sign. So let's have a theorem. And that theorem is called, very, very important theorem, very, very, very important for mains advanced, especially for advanced people. Leibniz integral rule under the integral sign. So what is the rule? Actually, the rule is you want to differentiate this under the integral sign. So first of all, this is a function of x and t. So it will replace t. Look at that, fx bx. Bx upper limit will replace t. Upper limit replace t. Okay, and ddx of bx minus lower limit replace t. So f of x ax into ddx of ax plus integration ax bx partial derivative with respect to x of the function and then the integration. Okay, this is the Leibniz rule. So I'm going to use this one. So look at that. What you have, upper limit is x square x, but the lower limit is constant. So according to Leibniz, I'm differentiating. So limit x goes to pi by 4. First upper limit will replace t. So upper limit is x square x, f of x square x, and the derivative of x square x is 2 sec x tan x. Okay, 2 sec x tan x, 2 sec x and sec x tan x. So that's gonna be sec square x tan x minus f2, and derivative of 2 will be 0. So there is no second part. Finish. And this is a function of t only. There is no integration part. All the functions will be function of t only in all your problem, maximum problem. And the derivative of the lower part, that is 2x. Now you substitute x equal to pi by 4, that's not vanish actually. So it is f2, and this is 2. If pi by 4, 10 pi by 4 is 1, so that's gonna be 8 over pi f2, 8 over pi f2. So your option is 1. So I'm using Leibniz theorem. Let me give you another problem on Leibniz theorem for your understanding. And this is the last problem of my presentation. So you have another problem. So if you put here x0, that will be 0, and 0 to 0, the same integration limit, the integration will be 0. So it is of the form of 0 by 0. So I am differentiating, I am applying L'Hopital's and also Leibniz theorem. So limit x tends to 0, 1 minus x will replace t. So that's gonna be cos x squared into ddx of x, 1 minus the lower limit is constant, so it's gonna be 0 derivative, and the denominator will be 3x squared minus 6. So the denominator cannot be 0 if you put 0. So that's gonna be 0 over minus 3, that's gonna be 0. So it is option 1. So that is the use of beautiful theorem, Leibniz integration theorem. So these are the important techniques, most important techniques I have discussed in my lecture. Those are very, very important if you are dealing with the problems of limit, especially L'Hopital's. You have to use 1 to the power infinity, sandwich theorem, a squeeze theorem, some important theorem based on mod x less than 1, mod x more than 1, and most importantly Leibniz theorem on derivatives under the integral sign. That's all. Thank you, all of you.